We are doing 14-10 today. Pages 235 to 236. I know it technically goes 235 to 238, but you know me, I'm only going to assign that one page because that's how I roll. Sure, but not right this second, okay? Alright, so today we are problem solving, and we're going to be making tables to help us, okay? You know me, I love to make a good table. I love to get out my hammer and my nails and some wood and put it together. I made that table back there. I didn't make that table back there. Nor am I making actual tables. I'm making math tables. We all know that. Alright? So, I do love making a good table or chart to help me, though. So, let's look here first, okay? And it says, they've already made a table for us, so we're going to use this as an example, and then I'm going to walk you through each problem and help you get started on each one, okay? We're not going to go through, you good?
Yeah.
Alright, we're not going to go all the way through to the end and find the answers together, but I'm going to help you get started on every problem on your homework, okay? So let's look at this first. It says, do you need to get a cough drop?
I think she does. I don't know.
Would you like to go get a cough drop? It's up to you. Okay. Alright, here we go. It says 4 friends record the distance they run at track practice. Brian runs 2 kilometers. Jack runs 1 kilometer, 200 meters. Devin runs 900 meters. And Aaron runs 1 kilometer, 350 meters. Now, it wants to know what is the order of the friends based on distance run from greatest to least. So, we're going to make a table to help us because can we accurately look at all of these together? Now, here's the deal. Is technically, yes, we could, couldn't we?
Yeah.
You can tell who's going to be, who's going to be the greatest?
Brian.
Brian. Who's going to be second?
Devin. Aaron.
Devin. No.
Aaron. Jack. Aaron.
Aaron, right?
Aaron.
Aaron, then who?
Jack.
Then Jack, then Devin. But it wants us to convert all of these into meters. So that's what we're going to do. Even though we could answer this problem without converting them into meters, it wants us to convert into meters. So they've made a table, okay? So we have our student here, and we have our 4 names, Brian, Jack, Devin, Aaron. We have the distance that they ran, the way it gives it to us, right? So Brian ran 2 kilometers, Jack ran 1 kilometer, 200 meters, Devin ran 900 meters, and Aaron ran 1 kilometer, 350 meters. Then it says rename as meters, okay? So 2 kilometers, how could we figure out how many meters that is? Well, how many meters are in 1 kilometer? Evelyn? 1,000. So, Evelyn, how can I figure out how many meters are in 2 kilometers? 2 times 1,000. It has 2 times 1,000 written in for me here. And then 2 times 1,000 equals, of course, 2,000, right? So that's over here in the meter section. Then this one, we have 1 kilometer, 200 meters. Okay? 200 meters is already in meters, so that can stay right here as the 200 on its own, right? But our 1 kilometer needs to be converted into meters. So, how many meters are in 1 kilometer? Charlotte? 1,000. So you can put 1 times 1,000, but we also just know it's going to be 1,000, all right? It's going to be 1,000 either way. So then we add those together. Remember, that's why I like to add that plus sign. We add them together, 1,000 plus 200, and we get 1,200. 900 meters is already in meters, so it just stays the same all the way across, right? And then 1 kilometer, 350 meters is done almost exact. It's done the exact same way as number 2 here. It's just instead of adding 200, we're adding 350, so we get 1,350. So then we get these numbers, 2,000, 1,350, 1,200, and 900. So we have Brian ran the farthest, then Aaron, Jack, and Devin. Now, let's look at problem 1 of your homework. In case you weren't sure, your homework's just going to be this whole page. There's like 5 problems total. 4 problems. 4. Oh, wait. No, because there's 1 on the... No, 4 problems total. But like I said, I'm going to help you get started on them all, right? I'm going to help you get started. Okay? What? Yeah, we're going to write in our notes in just a minute. Okay? So, let's look at these. Now, it says the weights of 4 textbooks are shown. So, we have all 4 textbooks. Math, science, reading, and social studies. Math weighs 1 pound, 13 ounces. Ooh, so we're not using the metric system. We're using the... What's the other system? Customary. Right? There's the metric system and the customary system. Right? Metric is easier in your head, right? Okay? But remember, you have all of your notes that have all of these conversions written down, plus those cheat sheets I gave you for the metric system, plus in your book on previous pages or past back homework. There's lots of places where you can find those conversions, right? Okay, so your math book is 1 pound, 13 ounces. Your science book is 2 pounds, 7 ounces. Your reading book is 15 ounces, and your social studies book is 1 pound, 15 ounces. It says complete the table, so we're going to fill out this table in a second. It says, what is the order of the books based on weight from least to greatest? This time we're starting with the smallest and going to the biggest, least to greatest. Okay? Now, I know that we could fill this in without even renaming everything as ounces, right? You guys could look at this. What's going to be the smallest book? 15 ounces, which is which book, Lauren? Which book is 15 ounces? Reading. Your reading book's going to be the smallest. What's going to be the greatest? Just looking at it. What's going to be the greatest book?
Oh. Science.
Mackenzie? Science. It's 2 pounds, 7 ounces. You could fill that out without ever doing this table, but it also wants us to do the table. So, let's look at the table real quick. We're going to do this first row together here. Okay? So, we have 1 pound, 13 ounces. Now, 1 pound, 13 ounces. Do we need to change that 13 ounces?
No.
No, it's already in ounces, but we're going to have to add it to whatever the pounds is in ounces, right? Now, you may need to look back in your book or in your notes. How many ounces are in a pound? Caroline, did you already look back?
No, I just know it.
What is it?
16.
16 ounces are in 1 pound. So, Caroline, I can do 1 times 16, which is what? 16 plus 13, and what am I going to get? How many ounces do I have then? What's 16 plus 13? Vincent? What? I shouldn't hear you. What? What's 16 plus 13? 29, right? So we have 29 ounces here. So our math book is 29 ounces. Okay? My science book is 2 pounds, 7 ounces. Who wants to tell me how I would rewrite that in here? How do you think I would write that in here? Who wants to give it a shot? Someone who maybe hasn't answered me that much today. I know. Give you a hint. Well, look at the one above it. It's going to be very similar. There's going to be one big difference. Emily, what are you thinking? Yeah, 2 times 16, because this time we have 2 pounds, so we got to do 2 times 16 plus what this time, Vincent?
7.
Plus 7. Why isn't it plus 13 again?
Because it's different.
Yeah, because, well, this is a different book, right? It has a different weight. All right, the math book weighed 1 pound, 13 ounces, but the science book weighs 2 pounds, 7 ounces. Okay? So we have a 7 there instead. You need to figure out the answer here. Okay, so you need to fill out the rest of this table. We filled out 3 of them together. That's almost half of them. You need to fill out the rest. Now, don't fill it out right now because we're going to move to the back. And I'm going to start helping you on some of these problems already. Okay? Okay? So let's look at number 2 on the back. it says, I know it's blurry. Hang on. I'll fix that for you. Okay. Oh, I just started casting that to Mrs. Lipscomb's TV. My bad. Sorry, Miss Lipscomb. You can start learning some of our math. How do you think the kindergartners would do with this math?
Terrible.
Yeah, probably. All right. All right. It says read and solve each problem. You can use a table to solve some of the problems. Okay? So, number 2 says the capacities of 3 water bottles are shown. Bottle 1 is 1 liter, 500 milliliters. Oh, we're back to the metric system. We're using liters and milliliters, okay? Bottle 2 is 900 milliliters. And bottle 3 is 1 liter, 150 milliliters. Now, again, could we answer this problem without filling out the table?
Yeah.
Yes, but it says specifically to make a table to rename the measures. So even though we can find the answer without the table, it still wants us to make the table, so we need to make the table, okay? Now, you could make the table in this little space here, but that's not a lot of room. I'm going to make the table in my notes, since we haven't taken any notes yet in our notebook. I'm going to go ahead and do that. In a second. You could do it right there if you think you can fit it, okay? I don't think I can fit it. I probably could, but I don't know that you can. Okay? So, don't exit out. Just write on there, like, my table is in my notes. So then if I ask to come see it, you can show me where it is, okay? So, we're going to make our table. And we have how many bottles? We have 3 bottles, right? So, I'm going to make this table 4 squares tall. Because I'm going to have bottle. I'm going to have weight. I'm going to have rename as, what are we renaming it as? What are we going to rename it as? What measurement do we want to get all of these to be? Milliliters, so rename as milliliters. And then I'm going to have milliliters here at the end. Okay, so this is my table. Sorry, I'll zoom in just a second. Let me just finish this up real quick so you can see it. Okay, can you guys see that? I'll zoom in a little bit. Can everyone see that? Okay, write that down real quick. Once you got that written down, then we'll keep moving. How we doing? You almost got this written in? What? What is happening?
What's happening?
You should at least be close to having this written in now. Okay, I'm gonna walk around real quick. Just a second. Oh, you wrote that small, Nancy. As long as you can fit everything in there, it doesn't matter. Alright. Looks like everyone's just about got it, so we're going to keep going. So first we have bottle 1. Bottle 1. That's what they're labeled, right? That's literally what it says, yeah? Okay, and how much does bottle 1 weigh? Let's fill out the information we already know to begin with. How much does bottle 1 weigh? Or capacity, sorry. How much does it hold? What's its capacity? Forgot this isn't wheat. Charlotte, what's its capacity?
1 liter, 500 milliliters.
1 liter, 500 milliliters, okay? Now, before I even deal with that, I'm just going to fill out all the information I already know. So I'm not even going to worry about renaming it yet. I'm going to go ahead and write in what I know about bottle 2. How much capacity can bottle 2 hold? What's bottle 2's capacity? And yeah, I really should change. I wrote weight here. I shouldn't have. I should have written capacity.
I can't see.
I know, it got super blurry again. I'll fix it in just a second. But what is, Mackenzie, what's bottle 2's capacity? 900 milliliters. I'll fix it in just a second, I promise. Let me write bottle 3 in, and then I'll recast it for you. It's annoying because it's not blurry on my computer, so I know it's the TV. I should write that down as a... What time is it? 8:35? I'll write that down as one of the issues. All right. Bottle 3, what's its capacity? What's bottle 3's capacity, Caroline?
1 liter and 150 milliliters.
1 liter, 150 milliliters. The nice part about this is I haven't written down anything that's not already in your book. All of the bottle capacity information is on problem number 2. This is the stuff they give you. So if you can't see it on the screen, shh.
Oh, yay.
If you can't see it on the screen, you can find it in your book still. So
I didn't look at the screen.
there we go.
100.
There we go. All right. Now that we have our table, I'm going to write a little bit of information up here to remind me. Who can remind me how many milliliters are in 1 liter? Who knows? Lauren?
1,000?
1,000. Do we agree?
Yeah.
Good. So I'm going to write that up here. 1 liter equals 1,000 milliliters. Oh, you can't even see that. Just to remind me while I'm doing this, okay? Okay. So let's start on number 1 together. We're not going to do the whole thing, but how could I rename 1 liter 500 milliliters as milliliters? Think back to what we did in our last 2 tables. Anyone want to take a stab at how you think we could do this?
Oh.
Lily, how do you think we could do this?
1 times 1,000.
Uh-huh. Is that it?
No.
What else?
Plus 500.
Yeah. 1 times 1,000. Whoops, that should be plus 500. Sorry, not 5,000. My bad. This whiteout is my best friend. 1 times 1,000 plus 500. Good. You guys think you can finish that table on your own?
Yeah.
I think you can too. But before you do that, let's move so I can help you with number 3. Okay?
Yeah.
Now I'm also going to write my notes for number 3 in here because I want to make, I'm not necessarily going to make a full table, but I am going to make a little bit of a chart, okay? So if we look at number 3, it says Jill runs every other day. So we have Jill here, right?
Bill.
And it says Elaine runs every 3rd day. So we have Elaine. Now they both start on Monday. It wants to know when will they both run on the same day. Again, so Jill runs on Monday, right? And she runs every other day. So does she run on Tuesday?
No.
No. Does she run on Wednesday?
No. Yes.
Every other day, yeah. So she is going to run on Wednesday. She skips 1 day in between, right? Does she run on Thursday?
No.
Does she run on Friday?
Yes.
Yeah. Does she run on Saturday?
No.
Does she run on Sunday?
Yes.
Now this next week, is she going to run on Monday?
No.
No. Is she going to run on Tuesday?
Yes.
Yeah. Is she going to run on Wednesday?
No.
No, but is she going to run on Thursday?
Yes.
What about Friday?
No.
No. What about Saturday?
Yes.
Yeah. Okay, so we could keep going, right? But I bet we might find our matchup here already. Okay, now it says Elaine runs every 3rd day. Okay, so Elaine also starts on Monday, but she doesn't run every other day. She runs every 3rd day. So we have Monday. Is she going to run Tuesday?
No.
No. Is she going to run Wednesday?
No.
No. Is she going to run Thursday?
Yes.
Yes. Okay, is she going to run Friday?
No.
Is she going to run Saturday?
No.
Is she going to run Sunday?
Yes.
Yes. And if we're being honest here, we might already have our answer. Right?
No. I'm gonna say that.
What day are they both gonna? What day are they both ran on Monday. What's the next day that they're both gonna run on the same day? Vincent? I know, it got blurry again. Someone wanna help him out?
Yeah. What? Barely don't have any time to look at
Lauren? Yeah.
it.
Thursday? Where'd you get Thursday?
Ah. Okay.
Where'd you get Thursday from? Well, yeah, but she runs Monday, Wednesday, Friday, Sunday, Tuesday before she ever gets to Thursday. Elaine runs Monday, Thursday, Sunday, and then keeps going. What's the first day they're going to run on the same day again? No, they both started on Monday. What's the next day that they both will run on the same day? All right, let's do it this way. Let's make a calendar here. Okay? Let's make a weekly calendar. Okay? I thought we could do it. I mean, some of you got it this way, but I want to make sure you all get it. So let's do it this way if we need to, okay? So we have Jill and Elaine. We have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. I made my thing too big, okay? Oh, sorry, it's all blurry again. Okay? So, Lauren, Jill runs every other day. She starts on Monday. She runs every other day, meaning she skips a day in between, right? So she runs on Monday. Does she run on Tuesday? What? No. Does she run on Wednesday? Yes. Does she run on Thursday? No. Does she run on Friday? Yes. Does she run on Saturday? Does she run on Sunday? Yeah. Okay? Now, Elaine runs every 3 days. Okay? So she skips 2 days in between. Okay? She also starts on Monday. She runs on Monday. Does she run on Tuesday? No. Does she run on Wednesday?
No.
No. Does she run on Thursday?
Yes.
Yeah, she runs on Thursday. Have they run on the same day again yet?
No.
No. Does she run on Friday?
No.
No. Does she run on Saturday?
No.
No. Does she run on Sunday?
Yes.
Yes. Are they both running on Sunday?
Yes.
Yes. So what's the next day that they're both going to run on, Lauren? What day do they both run on? Sunday, right? If you look here, we had Monday matched, and the next matchup was Sunday, right? Okay? Does that help if we put it in a week format like that instead of in a list? Does that make more sense?
Yeah.
Okay, the last one. So we already found the answer for that one, so there's a free answer for you.
You did?
Yeah.
Oh.
The last one says, Ariana, Vanessa, and Tiffany are all less than 10 years old. So they all have to be less than 10, okay? Okay? It says Tiffany is 3 years younger than Ariana. Vanessa is 1 year closer to Ariana's age than Tiffany's age. So what is the oldest that Ariana, Vanessa, and Tiffany can be? So this one is just thinking about what we know, okay? They are all we want to know the oldest that they could be, right? Because this could work in a few different numbers, but we want to know the oldest that they could be, right? What do you say, Lauren? Who would be 9? Okay, Lauren thinks Ariana could be 9. Let's try it out and see if it works. She says Ariana could be 9. Okay? Now let's check it with everyone else. It says that Tiffany is 3 years younger than Ariana. So, if Ariana's 9, how old would Tiffany be? 6. So that still works because they all have to be under 10, right? They all have to be less than 10. Okay? Then we have Vanessa. It says Vanessa is 1 year closer to Ariana's age than Tiffany's age. So how old would Vanessa be here? 8. Okay. Are they all less than 10?
Yes.
Would this work with any higher numbers?
No,
because that would put them older than 10, right?
Yeah.
Would it work with lower numbers?
Yeah.
Yes, but it wants to know the oldest they could be. So guess what? We just found the answer to that one too.
Oh my god.
So I gave you the answers to half of your homework today. You just have to go find the rest of them.
On number 4, can we say our teacher gives the answer?
No.
Yes. I forgot what.
Okay. So here's your answer right here. So you have the answer to number 3 and number 4, and all you need to do for numbers 1 and 2 is finish filling out the tables, which is good because you don't have a whole lot of time to work on your homework, but your homework shouldn't take you a long time, okay? Your homework, in case you weren't sure, because I guess I didn't really say it out loud, but it's 14-10 pages, 235 to 236, all. But we've already done half of them together. So,
I finished.
work on your homework. You got about 10 minutes to work on it.
I finished.
Great. Have a seat then. You got about 10 minutes to work on it before music. Let me know if you have any questions.